Good afternoon, everyone. Today we will discuss the thought. Today we will discuss the third part of the discrete Fourier transform. Uh, Today we will end up the properties of DFT, and we know that this is the basic formulas for DFT. Last class we will stop to DFT statement that is called circular convolution, where circular convolution is nothing but a DFT of y of n is equal to x1 of n circular convolution x2 of n. This is nothing but a y of k is equal to where x1 of k into x2 of k, where we find the statement that the convolution in one domain is nothing but a multiplication in another domain. Let me take the properties, and we know the statement from the left hand side. Y of k is equal to x1 of k into where x2 of k. Let us take the y of n, where y of n formula is nothing but simply k equal to 0 to n minus 1 y of k e to the power of j2 pi k n by n. And we know that y of k is nothing but a x1 of k and x2 of k. Just replace k equal to 0 to n minus 1 x1 of k into x2 of k into e to the power of j2 pi k n by n. And we know that replace the x1 of k and x2 of k in above equations. Let us consider x1 of k. X1 of k is nothing but simply where you can take the n already we can take. So here time variable is m is equal to n minus 1. Either you can take, so x1 of m e to the power of minus j2 pi k em by n. Why? Because already you can take the n value. Then take the x2 of k. Summation, here we can take the time variable L is equal to x2 of L e to the power of minus j2 pi k L by n. Now substitute the above two expressions in the equation 1. We can name it as equation 1. We can, not any issue. Just substitute x1 of k and x2 of k in above expression. You will get summation k equal to 0 to n minus 1. And summation m equal to 0 to n minus 1 x1 of m e to the power of minus j2 pi k m by n into, and again we have the summation L is equal to 0 to n minus 1 x2 of L e to the power of minus j2 pi k L by n into e to the power of j2 pi k n by n. We have the form. Now, the agenda is that you can convert all these expressions in terms of x1 of n convolution of x2 of n. Why? Because of we can take the y of n. Now, the show that x1 of n convolution x2 of n. So, for that most, you can know the x1 of n and x2 of n formulas. First, we have to be known. Then rearrange the all the formulas which we have 1 by n summation m is equal to 0 to n minus 1, and we have the formula x1 of m e to the power of, so x1 of m already we know that summation L is equal to 0 to n minus 1 x2 of l. Next summation k equal to 0 to n minus 1, we have the all the terms e to the power of j2 pi by n n minus m minus l into k. So it is the expression we know that. And first thing, first and foremost, you will learn the basic concept is called summation k equal to 0 to n minus 1 all to the power of k 1 minus alpha k 1 minus alpha when alpha not equal to 1 and it is equal to n where alpha equal to 1. So just like this is the expression. Now we can take alpha. Alpha is nothing but e to the, you can take the all this term. All this term is nothing but in, you can take the alpha. So simply what, when if it is the one, if it is alpha equal to 1 means you have only choice n minus m is equal to n, or else L is equal to n minus m. You have to substitute and it is the e power of 0 and you will get the 1. Now the continuity is that with that you have to substitute, you will get y of n is equal to, you have to substitute 1 by n summation m equal to 0 to n minus summation m is equal to n minus 1 x1 of m summation L is equal to 0 to n minus 1 x2 of L into n, where n and n will be cancelled and we know that L is equal, some L is equal to n minus m or simply m is equal to n minus L. Now replace all this term, y of n is equal to summation m is equal to 0 to n minus 1 x1 of m x2 of n minus m. Of course, it is the definition of the convolution, that is the x1 of m convolution x2 of n. These are the statement. Now the property of, I think it is the sixth or some seventh property, that is the property of what? Multiplication of frequency. Still we multiplication. So what? Multiplication of time or modulation property. Modulation property. Same, some DFT of already we state one statement, convolution in one domain, multiplication in another domain. So if it is the multiplication in one domain, then simply 1 by n x1 of k convolution x2 of k. Simply state. While property proof x of n, it is nothing but a summation n equal to 0 to n minus 1. We can take the x of n e to the power of minus j 2 pi k n by n. Just I need the confirmation of x1 of n into x2 of n. So that is nothing but a summation n equal to 0 to n minus 1 x1 of n x2 of n e to the power of minus j 2 pi k n by minus j 2 pi n by n. Just substitute only x2 because of we need from this convolution. X2 of n is nothing but a summation. We already use k, so here I can use some L, no issue. L is equal to n minus 1 x2 of L e to the power of j 2 pi ln by n. Okay, it is the capital X2. Now replace that summation n equal to 0 to n minus 1 1 by n summation where we can x1 of n already we know that where L is equal to 0 to n minus 1 x2 of n e to the power of j 2 pi ln by n, and again the remaining term e to the power of j 2 pi kn by n. Just rearrange the all the terms 1 by n summation L equal to 0 to n minus 1 x2 of L and summation n equal to 0 to n minus 1 x1 of n into e to the power of j2 pi by n into k minus L by n. So how you can write it as this expression? So it is the same, and it is nothing but a x1 of k minus L. x1 of k minus L. That is nothing but a 1 by L summation L equal to 0 to n minus 1 x1 of k minus L into x2 of L. So these are the proofs we have. And next property, and this is the property we can say it is the theorem we can say. Next, Partswell's theorem. So Partswell's theorem, what we can say? Dft of x1 of n into x2 convolution of n. This is nothing but a 1 by n summation k equal to 0 to n minus 1 x1 of k x2 star of k. Right. And we know that first we can take the x2 of n, where x2 of n is nothing but a simply 1 by n summation k equal to 0 to n minus 1 x2 of k e to the power of j2 pi kn by n. Now I will get the x2 star of n. So again you will take the x2 star of n k equal to 0 to n minus 1 x2 star of k, and again it will be converted as a j2 pi kn by n. So both side we can apply both side we can apply the uh, the term. So just take the dft of x1 of n and x2 star of n you can take. So what you will get, summation n equal to 0 to n minus 1 x1 of n 1 by n summation k equal to 0 to n minus 1. So x2 star of k e to the power of minus j2 pi kn by n. Right. According to that, we can convert what we required. 1 by n summation k equal to 0 to n minus 1 x2 star of k summation n equal to 0 to n minus 1 x1 of n e to the power of j2 pi kn by n. Simply 1 by n summation k equal to 0 to n minus 1, it is simply x1 of k. So where x1 of k and x2 star of k. And also you can take this all to our amplitude, then dft of, so you can take x1 of n mod whole square is simply 1 by n summation k equal to 0 to n minus 1 x1 of k whole square. Right. So here for this class, you will get direct 8 marks and 12 marks. These are the properties we have in a good manner. So next class, we will discuss the circular convolution topics. Thank you. Okay.